Hi, today I'm going to present my machine learning model called Predicting Hydration Level using Logistic Regression. In this walkthrough, I will explain the dataset, the steps I followed to train my model, how I evaluated it by using tables and charts, and finally, I will demonstrate the Gradio application. Firstly, I imported all the required libraries. Pandas is used for loading and handling the dataset. sklearn is used for splitting the dataset, scaling the features, training the logistic regression, and evaluating performance. I also imported matplotlib for charts and Gradio for the user interface. Step 2, I loaded the dataset from a CSV file. I displayed the first few rows of the column and the last few rows, as you can see here, and then there is shape, column, describe, and info as usual. And then I separated the dataset into features and target variables. The X is stored, the features are stored in X, and the variable is stored in Y, which is hydration level. Step 4, I converted the categorical columns such as gender, weather, and physical activities levels into numerical values because we're using logistic regression here. And then step 5 was splitting the dataset into training and testing. I splitted 80% into training and 20% into testing the data. And then after splitting the data, I scaled the feature values using standard scaler. Scaling puts all the features on the target on the same scale, which helps improve the performance and stability of the logistic regression model. Step 7, uh, we have to I trained the logistic regression model using scale training data, and then we predicting predictions on the dataset. Step 8, and then step 9. As we can see, I evaluated the model using accuracy, confusion metrics, and classification reports. Accuracy shows how many predictions are correct, while confusion metrics and classification report give me more detailed information about the model performance. And then step 10, which is this one, I created a summary table. One table shows missing values of the dataset, and another one shows the distribution of hydration level. These tables help me understand the data quality and class balance. Step 11. After that, I created a metric table, extra stuff for accuracy, precision, recall. These make the valuation result clear and easy to read. After that, I plotted charts to visualize the data, um, to show to show the predicted versus actual table, which were pretty accurate. And these are the last ending ones. Step 13. I plotted a few charts, visualizing to visualize the data. The bar chart, this one, the bar chart shows the distribution of hydration level, and the box plot compares daily water intake for good and poor hydration levels. As we can see, water intake plays an important role in the hydration. Step 14, confusion matrix chart. I visualized this confusion matrix as a chart. This helps clearly show the correct and incorrect predictions made by the model. And then there is our ROC curve, which you can see right here. I plotted this ROC curve, and calculated the ROC AUC score. This curve shows how well the model separates good and poor hydration levels. As you can see, the curve shows above the diagonal, which indicates good performance. And finally, this is the Grady application that I created. In this app, user can enter details like age, weight, water intake, activity level, weather. Um, to like the app then predicts the hydration level and shows the confidence of the prediction. This makes the model easy to use and real in like real world situation. Let me demonstrate. Age, you just put your age, gender, your weight, and how much water do you drink in a day, and then your physical activity level, weather of your area, and it predicts good or poor. Let's say I don't drink too much water, and now it's poor. And to conclude, I successfully built a logistic regression model to predict hydration level, evaluated it by using tables and charts, and displayed it using the Gradio, which we can see right here.